Today we can determine the atomic mass, or the weight of atoms, to great accuracy. As a matter of fact, the hydrogen atom is known to be 1.6735 times 10 to the negative 24th grams. And as we indicated before, it's kind of messy to have to write this big, long scientific notation number with that tiny little exponent right there. And so we use atomic mass units, or AMUs. As a matter of fact, they've defined the AMU, the atomic mass unit, from carbon-12. One of the isotopes that we talked about that happens to be the most prevalent one in the world. We say that carbon-12 is exactly 12 atomic mass units. And based on that, hydrogen is about 1 atomic mass unit, pretty close to it. In nature, samples have a mixture of these different isotopes. To determine a weighted average for each one of these, we can do a little bit of math, because that's the thing that's interesting to us. If you look on your periodic table, you can find the weighted average of all isotopes of carbon in a normal sample right up in the upper right-hand corner. It's 12.011. This number right here above nitrogen is the weighted average of all its isotopes. For oxygen, it's right here. For fluorine, it's right here. These numbers in the upper right-hand corner is called the relative atomic mass, or the weighted average atomic mass. So let's do a little bit of math in sample exercise 2.4 right down here. I'll zoom in on it down here, and then I'll also write down the relevant information on a piece of paper, and you can write it down as well. There are two well-known isotopes in chlorine that exist naturally. Like if you were able to come up with a sample of chlorine gas in a tank, and you were to analyze it, you would find out that 75% of it is chlorine 35, meaning that it has a total of 35 protons plus neutrons. If we looked on the periodic table, we'd see that chlorine has 17 protons, which means in this one it would have about 18 neutrons, or it would have exactly 18 neutrons, to be chlorine 35. There is also an isotope known as chlorine 37, and about 24% of naturally occurring chlorine is this isotope called chlorine 37. Each of these has this exact atomic mass units for weight. Now, if we wanted to know the average atomic mass, or the relative atomic mass, the average over a large sample of them, we would take and calculate what's called a weighted average. You actually have calculated a weighted average if you've ever had a class before where they say like 70% of your grade comes from tests, and 20% of your grade comes from some project, and 10% of your grade comes from a final exam. Well, how do you determine what your total is? Do you just average each one of these scores? No, you take a weighted average. 70% of it would come from this, 20% from here, and 10% from here. And that's the math we're going to do with this. So the math ends up looking like this. The average would be, take 75% of the 35.969 AMU massive chlorine 35. Notice I wrote the percentage as a decimal, and then add that to the 36.99 AMU sample of chlorine and take 24% of that. Add those two together, and then we'll have the weighted average. The weighted average turns out to be 35.45 AMUs. And then if you look on the periodic table, you can find, oh yeah, that matches. It says 35.45 right up here for its atomic mass. It matches the AMUs on the periodic table. That is how each atomic mass is calculated for the periodic table for every single element. Let's dispel just a little bit of confusion, because right now you hear many different words that sound the same thing. Well, as a matter of fact, there's about 8 different ways to say this thing that we just talked about called atomic mass. Atomic mass is also known as atomic weight. They're the same thing. Sometimes you'll hear it said formula mass or formula weight, because you're looking at a particular formula. And if it happens to be more than one atom, they'll add them together, and the atoms is weight or mass together. Sometimes you'll hear it termed molecular mass or molecular weight, or sometimes you'll hear it called the average atomic mass or average atomic weight. Or another one you hear sometimes is the molar mass or the molar weight. We'll get into that more in Chapter 3, but all of these mean the same thing. They mean find the number on the periodic table in the upper right-hand corner. Find this number, usually with a decimal, in the upper right-hand corner. That's what all of these mean. They mean what is that average or relative mass for a sample. So how do we know this number? How did we come up with these numbers for each one of these? In your next video cast, you'll watch a video on something called a mass spectrometer. And a mass spectrometer is the device that allows us to detect and determine what isotopes make up a particular element or sample of substances as well.